Right. So let's continue uh, about pH scale. Previous video or previously we discussed how to know the strength of acid and base. To know the strength of an acid or base, we have to use a scale called pH scale, which was invented by Sorensen. It was invented by Sorensen. Let us explore more about pH scale. The strength of an acid or a base is measured on a scale of numbers is called pH scale. Is called pH scale, right? So let us know more about pH scale. Okay. So pH scale, it has a values from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13. It consists of a numbers from 0 to 14. 0 to 14. What are these numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 and 14, right? So pH scale is a pure number. pH scale is a pure number, so it has no units. It has no units. So the pH scale has no units because of it is a pure number. It is a pure number. So based on the number on a pH scale, we can identify the acid has more strength or not, or the base has more strength or not. Means we can easily identify the acid is a strong acid or weak acid, either if the base is a strong base or the weak base. So it consists of 0 to 14 numbers. Here 7. 7, it is about neutral. If the substance having equal number of hydrogen ions and OH minus ions. It has equal number of hydrogen ions and OH minus means hydroxide ions. So that substance is we can called as called as a neutral substances. Generally pure water, or simply we can say that water is a neutral substance. Sugar solution also an example for neutral substance. Means neutral in the sense not a basic in nature, not acidic in nature. It is neutral. It has no acidic nature and no basic in nature. Sodium chloride solution, salt water. Salt water is also example for a neutral substance. Neutral substance, right? Then sugar solution is also example for neutral substance. Neutral substance. That means the pH of The pH of water sugar solution sodium chloride shows as a 7. Shows as 7. Right? Then acids are in case of acidic solutions. In case of acidic solutions. So 0 to 14. 0 to 14. That means this 0 to 14 or sorry 0 to 6 7 0 to 7 is explains about acids. 0 to 7 explains about acids, whereas 7 to 14 explains about the strength of bases. The strength of bases, right? So 0 1 2 3 4 5 6 7 0 to 7 acids, 7 to 14 bases, right? Here when we are moving from 0 to 14, 0 to 14, 0 to 14, the strength of or the strength or concentration of hydrogen ions, that means H plus ions, H plus ions, the concentration of hydrogen ions reduces while moving from 0 1 2 3 4 5 2 6 7 8 9 10 11 12 14. So the concentration of hydrogen ions reduces and the concentration of OH minus ions, hydroxide ions increases. This is very important thing. Keep in mind, right? So in a pH scale 0 to 14, when we were counting, when we were moving from 0 to 14, the strength of H plus ions or the concentration of hydrogen ions reduces and the concentration of OH minus ions are increases. So 0 to 7, 0 to 7, acidic nature decreases, acidic nature decreases, then means 0 to 7, 0 to 7, 0 to 7, acidic nature decreases because of the concentration of H plus ions reduce or decreases, whereas 7 to 14, 7 to 14, 7 to 14, basic nature increases, due to OH minus ions increases. OH minus ions increases. Then what about that 7? It consists of equal number of H plus and OH minus ions. 0 to 7, concentration of H plus ions are decreasing. At the 7 means 7 to 14 means 0 to 7. 0 to 7, concentration of H plus ions are decreases. Then 7 to 14, concentration of OH minus ions increases. So what will happen? Acidic nature is decreases, it become neutral and the basic nature increases. And the basic nature increases. That means at zero, it consists of maximum maximum H plus ions. At 14 has maximum OH minus ions. So the acid shows 0 on the pH scale, 0 on pH scale, then its concentration is maximum. If any base shows 14, any base shows 14 on a pH scale, it has it is an example for concentrated base, highly concentrated base. So from this 0 to 0, 1, 2, 3. 0, 1, 2, 3. 0, 1, 2, 3. If the pH scale of any acids are 0, 0 or 1, 2, 3, then we can consider as strong acids. Whereas 4 to 6 or 4 to 7, 4 to 6, 4, 5, 6, 4, 5, 6 are weak acids. Then 8, 9, 10, 11. 8, 9, 10, 11. 8, 9, 10, 11 are the weak bases. Whereas 12, 12, 13, 14, 12, 13, 14 are the strong bases, right? So okay, then 10 up to 10, okay, no problem, up to 10. 8, 9, 10. 8, 9, 10 is weak bases. Are the weak bases. 11, 12, 13, 14 is the strong bases. Examples for strong acids: hydrochloric acid, sulfuric acid, nitric acid. Hydrochloric acid, sulfuric acid, nitric acid are the examples for strong acids, which are already discussed, because of they have maximum concentration of H plus ions. Whereas coming to strong base, sodium hydroxide, potassium hydroxide. Sodium hydroxide, potassium hydroxide. Sodium hydroxide, potassium hydroxide are the example for strong bases, because of they have more concentration of OH minus ions. OH minus ions. Then coming to example for weak acids, acetic acid, CH3COOH. Then carbonic acid, or citric acid, oxalic acid, that means organic acids are example for weak acids, because of they have less concentration of H plus ions. Whereas weak bases, ammonium hydroxide, magnesium hydroxide are some example for weak bases. So because of they contain less concentration of OH minus ions. See, strong acid become strong to weak, neutral. Basic nature increases. So 0 to 7, acidic nature is decreasing. Then 7 to 14, basic nature is increasing. So in case, right, if any solution, either acidic nature or basic, we don't know, depending upon the concentration of H plus ions, we can classify that, we can identify that first of all, it is a base or acid. To know it is a strong acid or strong base, so by using this pH scale, by using this pH scale, we can easily identify which is a strong acid, which is strong base, which is weak acid, and which is the weak basis. It is the weak basis. So when if any solution, if any solution has a pH value 0, pH value 0, then other solution contain pH value is 6. 0, 6. Two solutions are given us and asked us identify is it acidic nature or basic nature. So we can identify that the first solution pH scale is the pH scale and pH scale shows 0. Then the second solution shows 6. 0 in the sense when you have the idea 0, that means strong acids. So the pH of any solution is 0 or is 0, then it is a strong acids. If the pH of solution is 6, then it is a weak acid. How we can say exactly it is acid? How we can say we can exactly is acid? We know the pH of any solution between 0 to 7, 0 to 7, it is a acid. So even though the solution is acid, based on the reading, based on the number on the pH scale, even on the pH scale, we can identify the given solution or the given acidic solution is a strong acid or a strong acid or a weak acid. Similarly, if any solution shows 9 on a pH scale, the other solution shows 12 on the pH scale. So 9 and 12, 9 and 12, that means the given solution is a basic solution. From this, we can easily identify the given solutions are strong bases or weak bases. How? The pH of weak bases is 9, then the pH of strong bases is 12. Is 12. So in this way, by using the pH scale, by using pH scale, we are easily identify the acids or we can identify the strength of an acid or a base based on the number on the scale, based on number on the scale, right? So in class 10 there are no problems regarding to uh, pH value. Maybe in examination will ask, they give some values, they have given some values of different solutions and ask them and asked us identify which of the substances are the bases, which are the substances are acids, which are strong acids, which are strong bases, which are weak acids and weak bases. In this way, the questions will become in examination. The questions will become in examination. So, hope you understand pH scale. Hope you understand the pH scale, right? So, concentrated hydrochloric acid is a strong acid, sulfuric acid also strong, nitric acid also strong, right? Some of the examples. Some examples for then milk 6.5, milk 6.5. The concentration or the pH of milk is 6.5. Right. So let us know some examples for concentrated acids and strong acids and weak acids. So concentrated hydrochloric acid pH is 0, dilute hydrochloric acid is 1.0, gastric juice we already know our digestive system contain gastric juices, nothing but HCl only. Its concentration is 1.4 or the pH. Lemon juice it is 2.5, vinegar 4.0, soft drinks 6.5, milk 6.5, milk 6.9, little acidic in nature. Then we know water generally is a neutral, its pH is 7, its pH is 7. Then saliva, saliva, saliva before eating, it is 7.5. Saliva after eating, its pH is 5.8. Its pH is 5.8. Blood pH is 7.8. Toothpaste is 8.0. Toothpaste is 8.0. Then household ammonia, household ammonia is 11.6. 11.6. Dilute sodium hydroxide, it is 13. Concentrated sodium hydroxide it is 14. It is 14. X 7.8, right? So these are the pH of some substances. See, saliva, this is the very important, right? There is a chance in asking examination also. The pH of saliva before eating, after meals, after eating. Before meals, saliva pH is 7.4, a mild basic, right? After meals, after eating, the pH of saliva is 5.8. 5.8. So, mild acidic. That's why this is the very, very important. Right? Blood 7.8, mild or weak basic nature. Toothpaste 8.0, weak basic in nature. Then X 7.8, weak basic in nature. Household ammonia, not for ammonia is used for fertilizers, used as a fertilizer for plants. So that is different. Household ammonia we are using for cleaning purpose, whatever. 11.6. Dilute sodium hydroxide 13.0. Concentrated sodium hydroxide it is a 14. It is a 14. Right? So this is about pH. This is about pH. The strength of an acid or base is measured on a scale of numbers, is called pH scale. So hope you understand. Read your textbook thoroughly, underline, make your own notes, right? Then this concept is very, very easy to understand. Very, very easy to understand. Thank you.